In episode 9 of Mobycast, Jon and Chris discuss a few of the AWS services they're currently evaluating. Welcome to Mobycast, a weekly conversation about containerization, Docker, and modern software deployment. Let's jump right in.
Welcome, Rich and Chris. Another Mobycast today.
Let's go. Hey, Jon.
Pretty good. So usually we do these once a week, but Chris is going on vacation to where are you going, Chris?
To an undisclosed location far, far away. Now I'm going to Rome, Italy. So the eternal city.
Nice. Well, that should be really fun. Looking forward to seeing pictures and hearing your stories. Unfortunately, I don't think the rest of the audience will get to see the pictures, but maybe you can share a story when you get back.
Yeah. And the real reason is I can't get good coffee in Seattle, so I have to go to Rome.
That's awesome. I was just in Seattle visiting you last week, and I think there was some decent coffee there. In fact, I bought some coffee from Elm Street Coffee Roasters, and I think I bought $40 worth, and it is already gone.
Wow.
So disappointed. It was so good. Both my wife and I were just like, oh, I love this coffee. And yeah, so we're recording a day after the one we did yesterday. And in between yesterday and today, we pushed Mobycast live. Rich, that was some great work. Thank you for doing that. I imagine that's been most of your time though, between yesterday and today, yes?
Yeah, all of my time, I think. For the most part, working through a few bugs and just getting everything set up.
Right. Mostly the same here. Getting some mailing lists set up to let people know about it. So it's exciting. We're hoping that a few people like what we have to say. And so today we're going to do a continuation of yesterday's show. We talked about several of the AWS services that we like and that we use that are core to what's happening at Kelsus. And a couple of those, for example, Elastic Beanstalk in particular, and a little bit with Lambda. And we talked about, what we don't like to use anymore. With Lambda, it wasn't that we don't like to use it. It's just that we don't like to use it for everything. So today, there were a couple of services that are core to what we do that we didn't hit yet. So we want to talk about those. And then there's another list of services that we have that we're excited about, that some of them we've used a little bit and are anticipating using a lot more. And some of them we're still in the research phase with and hoping that we might use them because they're looking very promising. So to get started, the first things that we're going to talk about are the ones that we absolutely do use and they're core to what we do. So the first one of those is one that we've used for just years and years. And everybody that knows it, AWS should be familiar with, which is S3, but it still bears defining and talking about. So go ahead, Chris. What is S3?
S3, three S's. Simple storage service. This is one of the very first cloud services offered by AWS, and essentially what it is it's completely elastic file-based storage. So you can write files to essentially folders, read them, and over the years they've extended it to just tremendous number of different ways of doing that and manage actual life cycle of storage. But the important thing is that this is file-based storage. So it's not like block level storage. It's not a raw disk, right? It's files, and so those files can have permissions, and you can do all the things that you do with the files, and it just serves as one of those core fundamental services that a lot of applications need.
So it's a place that you can store files. So if your applications need, maybe you're uploading stuff, users are uploading files via your application, and you need a place to put them. S3 would be a great place to do that. Maybe you have an image sharing app or something like that, or a video sharing app. You might put your videos or images in S3. And I think a good way to clarify what you said about it not being block level storage is that you can't have S3 be the disk drive for a machine. You can't say, hey, I want to run my Microsoft Windows operating system on this virtual machine, and the disk is going to be S3.
Correct.
Cool. So I almost think of it as a special place with, I guess they're called buckets, but it's like folders that are just for files that are of a certain type. They're just files.
There's just so many different use cases that pop up. Like you said, a great one is, you have an app that wants to support image uploading, and then be able to view those images and share them. So storing those in S3 is a perfect use case for that. Another one would be just kind of sometimes app configuration information. You want to store that in files, and store them in S3s, because the great thing about S3, of course, it's a cloud-based service, and so it means now it's available to all your applications, all your machines that are running your application. So if you have a cluster of machines running your app, you don't have to have those configuration files on each one of those servers. Instead, they can all just go to this known place, this S3 bucket, and go read the configuration from there. And you have one place where you're managing that file.
Right.
I was going to actually just jump in real quick. But this isn't a CDN service, right? And so I always kind of get tripped up with that. Like, what would be the difference? Or could you use S3 as a CDN, so that you just have a different location through which you're loading those files? But that's not what it is, right?
So right. So what a CDN is, so a content delivery network, what that is that's basically pushing. It's a cache of content that gets pushed to the edges of the network so that it's closer to the consumers of that, to increase the speed. So, and obviously, since it's a cache of content, it's important that content it shouldn't be changing all that frequently. So this is really great for like static web assets, images, some HTML files, sometimes media files that aren't changing. The thing is, though, is that you can combine these two things, right? So you can have you could use something like S3 as the origination source for all that information, and then you can then integrate it in with your CDN to say, this is the source of the information that I want on my CDN. Suck up these assets and then distribute them out to your edge locations and have that be the origination, for my content. So definitely they can go hand in hand, but the CDN is leveraging S3.
I want to explore that a little bit deeper just for a second. So it seems to me that if you wanted to, you could say, all right, all my content for my whole web application is served directly by S3. I'm not using a CDN. And the question I have, that I've never tested this, but the question I have is, can S3 scale to any level of load? So imagine you have millions of users. Can S3 handle that?
It can handle quite a bit. I mean, there are actual kind of like service guarantees for the amount of traffic that you can handle with an S3 bucket. And you do get into situations where you need to kind of take into account the way that partitioning is done, and that could potentially be a limitation on how well you scale. But for the most part, S3 is designed to scale kind of infinitely. There's very little hard limits on it as far as like throughput. It's just that there may be some design decisions that you have to make in order from just a partitioning standpoint, so that you don't have everything go to one particular bucket. Right on.
And so if you have content that's changing frequently, but that is files, then S3 might be a good place for it to serve even to a very high traffic, large application. But if you have content that's not changing very often and you have global users, you may want to get that content closer to those users so that they're not experiencing latency, say from Argentina to the United States. There might be a 300 or 400 milliseconds of latency that using a CDN can help you avoid.
Absolutely. Yep.
Cool. So there was one thing that I remember you telling me about recently that you had learned about how S3 works under the covers, Chris, that I think is worth sharing, if you can recall what it is. I actually can't recall off the top of my head, but it was basically about how the files are stored under the covers. That was really surprising to me because I didn't expect that it could be as performant as it is.
Yeah, and unfortunately, so this is actually another service that we haven't talked about yet, right? Which is we were actually talking about Elastic Block Service, EBS, and so EBS is the block level version of storage that Amazon offers as a service, as opposed to S3, which is the file based service. And kind of like for me, the thing that was kind of slightly mind blowing was that I always thought of EBS as you are getting access to an actual disk, and you're, for all intents and purposes, you're just mounting that disk as a volume onto your machine. But the truth is that EBS, it truly is, it's a software based service, and so there are many thousands of actual physical disks, and the blocks are being distributed across them as their software algorithms deem fit. But whenever you request a block, read a block, write a block, it's actually going through software, and the software is making a network request essentially to figure out like what disk to go talk to. For me, that was just like, wow, I can't believe that, you can basically have disk access, the speeds that we're used to with that, but it's really going over the network. And it's going through software, which is kind of mind blowing.
Okay. So it wasn't about S3. And I had thought that one service was using another that was unexpected, like EBS was using S3 under the covers or something, but that's my memory is just failing me here.
Well, it gets complicated, right? Because there's over 100 AWS services, and they very much, many of these things are built on top of each other. Mm-hmm. So like a great example is, RDS, you can do encryption at rest with your RDS databases, and it's just a button click in the console to do so, or a switch in the API, the command line API to set that up. But it's just leveraging S3 encryption to do that, right? So S3 itself you can encrypt your files, and that ends up being a building block for a lot of other services. Just S3 itself is a building block for a lot of other services inside AWS to do this stuff. So it's kind of interesting how all these things just kind of plug together. There's foundational pieces, and you just build on top of that stuff. And that's one of the reasons why AWS is able to just their pace of innovation is increasing. It's definitely not linear. It is an exponential curve when you look at what they're doing and what they're launching. And part of that is, they're hiring like crazy, and they do have an army of people. But the other thing is that it's just becomes so much easier now that those foundational pieces are in place. You just start gluing these things together, and it's the pace just increases dramatically.
So the singularity is going to be brought to us by AWS.
Oh, for sure. Yeah. And it's definitely before 2038. Okay.
So the next one that we have on our list, because I think we've done a good job of talking about S3. The next one we have on our list is CloudWatch. It's another service we use a lot. There are parts of it we love and parts of it we don't. So maybe you can tell us what it is, and we can get into it.
Sure. So CloudWatch is a big, huge beast of a topic, and it's very, very broad, but in kind of generally, it's all about like monitoring and getting insight into what's going on with your resources and software that's running inside the AWS cloud. So you can get metrics, you can get graphs, you can set up alerts and alarms to know like, hey, let me know when this EC2 machine is getting passes 90% disk utilization, so that I'm getting close to my disk filling up and I need to do something. Or let me know like when my CPU is above a certain threshold or maybe below a certain threshold. So getting that kind of that real-time insights into what's going on in the machines, and that feeds in as inputs to a lot of the other services inside AWS as well. And we can kind of peel that back and talk about that a bit more. But at a high level, it's a means for monitoring and getting data about all the various services and resources that you have inside AWS.
So I guess from there, I kind of get what it is, but it may help to put my head around it if we can talk about how we're using it in some kind of concrete way. Can you give us an example on a project?
I think we have used CloudWatch for alarming. So we've created CloudWatch alarms to let us know when things like network bandwidth is above a threshold that we're not expecting, and so we'll send an alert. And so we'll get an alert. At the end of the day, it might show up as an email or some other maybe a Slack message or something like that let us know that, hey, this alert got triggered. We've also used it to create custom dashboards, which is kind of nice, right? So you can kind of have custom metrics for what's important about the health of your application. And so we've used CloudWatch to create these application specific custom alerts, like we're expecting regular activity in our application in our database, and if we don't see like something happen at least once an hour, then that's when we need to look in closer to it, because that may indicate that there's something wrong with that system. So we created a custom alarm for that and a dashboard to go along with it, so we could visualize it and see what's going on with that particular service. So it's again very, very customizable, very, very broad, and very feature packed, and just so much that you can do with it. It just really depends on like what it is that you're trying to do and what you need.
When you mentioned that it can feed into inputs of other AWS services, is it something like you could set up that it makes decisions for you? So if you reach 90% utilization, that it can spin up other servers or something like that? Or is it really just for sending off that data to a human to make those decisions?
Mm-hmm. No, absolutely. So you use it to inputs to other things. So, that's a great example. So you can have a cluster of machines being managed as an auto scale group, and you can define scale up and scale down policies for that ASG. So when you could say something like when maybe it's CPU is the metric that you're going to monitor on that to determine when you need to get bigger, your cluster needs to get bigger. So you can set a CloudWatch alarm on that to look at that and see when, if the average CPU goes above a certain threshold. And when it does, you can then say, hey, I'm now going to trigger a scale up event on my ASG. And so that will automatically then say, okay, ASG, instead of being 5 nodes, we want you to be 6 nodes. So go ahead and create a new node to handle that additional load. And then you can do the reverse as well, right? You may have had maybe your app has peak times for 2 hours during the day, and maybe you need twice as many machines during that time. So you'll have these scale out events that happen, but then you don't need those machines, right? So you can have the converse. You can say, hey, once CPU utilization goes below a certain threshold, start killing machines and take them out. So bring that back down so we're not paying for resources that we don't need.
I think that right there, CloudWatch's easy integration with auto scaling is the killer feature that probably draws people into it and gets people locked in on AWS and CloudWatch over, using some other monitoring tools that are potentially better and definitely prettier, like New Relic and Datadog, because setting up another alerting service to do your auto scale groups just feels like more steps. You're not using just that super tightly integrated AWS stuff. Because I think auto scale groups can listen to, you can. There are other tools out there that can send an API request to say auto scale group, increase or decrease. But CloudWatch, it's just a few button clicks and you're there.
Yeah, absolutely. And we touched on this the other day too, as well as like there's for any particular aspect of your application or system that you're trying to do, there's various places you can get that functionality or service, and you can use the AWS versions of it, or you can go outside of it. And then you just have to kind of do the pros and cons, right? Like, is it worth, you can't discount that network effect of using these technologies that are really integrated all together versus like, okay, if I use this outside tool, what's the additional steps I have to do? And I better get there's got to be a really good reason for doing that, whether it's like I don't want better lock-in, or it's some factor of X better functionality type thing. But yeah, John, you're totally right with like something like CloudWatch and ASGs. Like it would be very hard to come up with a scenario where it doesn't make sense to use that.
Right. Yeah. And just identifying what is that feature for the various AWS services. What's the one that maybe, because across the board, I think AWS does suffer from poor documentation and some UX and just kind of headache. And so every time you decide, okay, we're going to commit to AWS, you have to identify the feature that just makes it worth putting up with that. And I think in CloudWatch's case, it's this one. And there was another one, I think in SNS's case, it's like, well, you could use another push notification service, but is there any other push notification service that actually is a full-on publish subscribe message bus that lets you fan out to all the AWS services? No, there's not another one of those. So let's use AWS SNS instead of, I can't remember the name of another push notification service that's out there, but there are several.
Twilio?
Sure, yeah, Twilio.
Layer.
There you go. There used to be Parse, but it is no longer with us.
Mm-hmm.
So yeah, CloudWatch. There was a few things that we don't like about CloudWatch. I think you touched on it yesterday, but maybe we can just touch on that one more time real quick to close out our CloudWatch conversation.
Yeah, again, I think it boils down to just what you're trying to do and what's the right tool for the job. I think we for a lot of the insights that we have, we do like our logging to give us access to that, and also to let us know when things are not going well. So kind of application health, kind of like what's going on in the system. A lot of that comes from the logs themselves. Things like kind of like these core metrics of like CPU utilization and disk utilization, they become less of an issue because we're running our apps on top of ECS and a cluster, and it ends up there's just much fewer things to manage, and they're usually provisioned such that not so much of an issue, and we can use things like auto scale groups to scale up and scale down accordingly. There's also, in the monitoring space, there are some really great options out there from other companies that they are, in a lot of cases, a factor X better. So things like New Relic, things like Datadog, things like PagerDuty. A lot of these tools give you some even much more detailed information on what's going on in your systems and alerting, and they're just really, really aimed and geared around that. So when it comes to just lifecycle management, performance management of your applications, those warrant a closer look. So us personally at Kelsus, we use New Relic for a lot of this monitoring, alerting, insighting, performance management, and less so on the CloudWatch side for those kinds of things.
Great. And I think that one last thing I want to say about monitoring and watching applications that are running is that, we look towards observability as one of the key things that we care about. So when an error does, it's one thing to be able to look at a big screen that has a dashboard and lots of green parts on the dashboard and feel cozy that your application is up and running and happy. But it's not a world where you can really see everything by doing that. And most companies don't want to have operations engineers that all they do is sit around all day looking at green dashboards. But what you really do want is when something goes wrong, you want to be able to know that it happened and then be able to dig into that and really uncover why it went wrong and be able to observe everything about the thing that went wrong. So that's a focus of everything we do when we build with CloudWatch or with New Relic or with some of the other tools that we use like SumuLogic and Rollbar. So let's move on from CloudWatch and talk about another just all these topics are just so enormous. But we're trying to do a high level overview of these AWS services. So a big one that I actually kind of overlooked for a long time, but Chris, you recently went to a talk from AWS itself about it, is DynamoDB. I overlooked it just thinking that Mongo is the giant of serverless NoSQL databases. But it seems like DynamoDB may be worth a look. So what? And we are not using DynamoDB for anything right now, right?
Correct.
But we are using Mongo for things and have used it quite a bit in the past. So what was your takeaway learning a little bit about DynamoDB from AWS?
Mm-hmm. Yeah.
And what are they first, I guess? Yes.
Sure. Yeah. So DynamoDB is one of the NoSQL database offerings from Amazon. Basically it's a document-based data store, key value based data store type thing. So it's not relational data. It is a flexible schema format of data. So really, usually this ends up meaning you're storing JSON documents. So you're writing them and pulling them out. And so there's certain use cases where like that's exactly the kind of format that makes sense to use. And so using a relational database wouldn't be the right match for some of these use cases. And so DynamoDB is Amazon's kind of premier NoSQL offering, and it very much directly compares against MongoDB, which MongoDB is by and large probably like the king of the hill in this space. They're definitely were one of the first out there. They've been around for quite some time. I started using it in production apps back in 2012. And I think Mongo had been out for at least a year or two prior to that. So it's been around for quite some time. Although that said, DynamoDB, they started work on that in 2006. So it has been 12 years that they've been working on it as well. So pretty.
Chris, I think that's a common misconception, because I didn't know anything about DynamoDB before you talked to me about it, and I knew it was their Amazon NoSQL offering, and I just assumed, they just want to take market share away from Mongo, so they built some in-house thing, and that's absolutely not the case.
Mm-hmm. No, this is a really fascinating story for me. It's very personally relevant to me, and if I may, maybe I can go back a little bit, kind of in time, and kind of explain, because it might help explain just this space. But years ago, I was at Microsoft, and we were working on. I was working in MSN, which is Microsoft Network. So it was basically providing all these services as web apps to a user base that was millions of people big. And we were doing this at a time where being able to adequately scale your data layer was very, very difficult. Really, the only options were use a relational database, and you have to scale up. You scaling out wasn't an option. So scaling out meaning you can partition, cluster your database and just add more database nodes into your system to scale out. Instead, you couldn't do that. You really just scale up, which means you have to buy a bigger machine. And you get to a point where there's no bigger machine you can buy, right? And you literally hit a wall. And so we were having problems like that at Microsoft, and kind of realized that a lot of the data that was being stored in these things, it wasn't relational. It was document-based data. So I left Microsoft with a colleague. We went and founded a company to kind of address that space of like, how do you build this basically a clusterized version of database storage for documents, specifically for these internet applications. Turns out we were kind of ahead of our time. The ecosystem wasn't quite right, and we also were victim to the .com bubble bursting. So kind of unfortunate timing. But in 2004, Amazon was having the exact same problems that we had at Microsoft. So their site was scaling. They were getting more users. they were coming. They have very much peak periods around the holidays, and in 2004 they were having these huge issues with scaling their backend database. It was just not staying up. It was basically full, just completely full. It was bursting at the seams, and they had problems just keeping their site up. And they kind of had the same realization that a lot of the data going in here wasn't relational. It was really just these documents. So that started the process for Amazon to go say, we need to go build our own database that really addresses this space. They started that work in 2004. They had something in place by the end of 2005 as a kind of an interim approach. And then that led to the work that became Dynamo. So Dynamo was created specifically to address the pain of how do you scale to these massive loads, and just with the realization that the data that's being put in there is not relational, and you need a new type of database for it.
That's super fascinating. And I think, I guess I have a question. So a lot of times it seems like, a piece of software that's that old may have barnacles on it that may actually be bad for it, because maybe DynamoDB is too specific to the Amazon problems that they were having in 2004, and it also carries, has to be backwards compatible to a bunch of 2004 types of technologies. Did you get that sense at all when when learning about it?
No, I think that that even though they may have started on it in 2006. It was purely like an internal tool. And it was based upon, just this original thesis, if you will, of like, this is how you build something that is massively scalable, that deals with this NoSQL data. It was used completely internally at Amazon for some amount of time. And then the decision was made. It's like, you know what, we should open this up, offer it as a service to everyone else. That happened. That definitely wasn't in 2006. I don't know the exact date when they opened up DynamoDB to the rest of it, but I'm pretty sure it was around 2013, 14, 15 timeframe, somewhere in there. So it's relatively recent that it's been offered as an actual service that other people can use as part of the AWS Services Suite. And I'm very, very confident that the code that was written in 2006 is very little of that is probably left in what is now DynamoDB that Amazon offers.
Then that helps explain also why many of us felt like DynamoDB was just a Mongo clone that the AWS was putting out there to, if it came later, if it didn't get to the public until 13, 14.
Yeah, the awesome thing, that's just the fascinating thing about this is that like these systems were created out of necessity. Like they are solving very real pain, and they were independently developed out of that necessity. That said, like how many folks actually have that deep pain of, I have millions and millions of users, and how do I scale my databases? But that is why they exist.
So one thing right off the bat that's painful about using MongoDB is that you have to, with AWS, is that you have to install it. You have to fire up some EC2 instances, install it, and then maintain it. You can use a MongoDB as a service through another company like MLab. That's totally an option, and that way it's a totally managed service. I know that we have Mongo in one of our projects. Are we using an MLab, or are we hosting it ourselves?
So we are definitely hosting ourselves, primarily for just performance reasons, right? So otherwise, you're making that network connection out of your AWS data center, right, to go talk to some other place, and you create a very hard dependency, right, as well. So like, what happens if that service goes down? So we personally do run MongoDB ourselves. We have installed them. We have to install them on EC2, so we have to manage those. We obviously want high availability and fault tolerance, so we run it as a replica set, which means we need 3 separate machines all running the same MongoDB, with one acting as the primary and the other 2 as the replicas. So that gives us the performance, the availability, and whatnot. But it also it is a headache when it comes to operating and maintaining it, patching it, making sure we have backups, being able to restore. We have to do all that ourselves, and that is a lot of pain.
Mm-hmm. It's why we use RDS, why everybody uses RDS, is to just avoid those kinds of pains. Mm-hmm. So another question is, did you get a sense that there were any other kind of killer integrations that DynamoDB has to other AWS services that would be, coding or more work to accomplish in Mongo?
Yeah, and this is the common theme, right? That it's the network effect of staying within the AWS ecosystem. So no surprise, DynamoDB is very much integrated in with a lot of the other core services and technologies that Amazon has. So a really great kind of use case is when you want to be when you want to have a more event driven architecture. And so DynamoDB, you can it has a feature called DynamoDB Streams, and what that is it's basically it's a streaming transaction log of all mutable operations that are happening on your database. And so every time something is mutated with a create, an update, or a delete, there's an event that's emitted onto the stream, as a journal letting you know like this happened. You can then have that stream go to a Lambda function, and now you can start doing things to trigger actions based upon these events. So if you want to let's just say you want to send an email whenever someone creates a new contact, like a user, like a new user's added to the system. You just want to send an email, right? Because you're just launching your app and you're going to be excited about seeing user signups. So turn on streams, set up a Lambda function to read off that stream. When the Lambda function gets invoked, it has the event record in there. You can look at it and see, hey, what type of what collection, what table was this is this create being done on? If it's the users table, go ahead and use SES to send an email, or maybe it's an SNS message that you're sending. So very, very powerful event-driven system with very minimal amount of work on your part.
That's super interesting. And so in order for us to start using that, or for other companies to start using that, they would either need to migrate or have a new greenfield project where they could choose it as the data store. Did they talk at all about specific migrations from Mongo? Do they have a path for that?
That ends up being a very, custom specific thing. And Amazon, like many other companies, they have the professional services that They do have solutions architects that will, for a fee, they will absolutely help you do that work. The good news is this is one of the reasons why MongoDB was so popular, is that it's so easy to get started, right? Like you don't really have to do anything. You just basically have to install the service, and like you can even, your tables can be created on the fly. Like you don't have, there's nothing you're out of the box running immediately. And DynamoDB is no different there as well. So it really just depends how much work it's going to be to migrate over. Is really depends on your application. How you've developed it. If you have your database logic kind of modularized and isolated into one area of your code, then it's probably going to be a lot easier than it is if you just have stuff scattered all throughout your code base. And that's going to be much more work. So
cool. I was wondering if they had some sort of magic thing, you can imagine they would have something that could read collections and documents off a Mongo database and pull them in, and then maybe some sort of thing that was like essentially their query language could be transmogrified into Mongo's query language, or vice versa. But it sounds like maybe not.
They do, Amazon does have a database migration service, and I'm sure that this is definitely one of the source destinations that they do. But what that's doing is that's just taking your MongoDB and moving it over into Dynamo. But your application has to change. Yeah.
Yep. Cool. Well, I wouldn't be surprised to see DynamoDB take a seat at the table in the previous list that we had talked about of core services that we use.
The other thing too, I will point out is that did recently go to this DynamoDB summit here in Seattle at Amazon HQ, but I really got on my radar when I was at reInvent last year. So many of those talks were mentioning about DynamoDB as just like this core thing that the Amazon services themselves are all using. So that's when I really pricked my ears up, and I'm like, wow, this is really powerful. It's really integrated in. It's battle tested, and you don't have to manage it. It's a completely managed service. So things like backups and restores, like I don't have to worry about them. Things like scaling servers, patching servers, don't have to deal with that. They have some amazing technology in place to have essentially multi-master configurations with Dynamo. So you have just incredible scalability and availability and fault tolerance story. Pretty amazing.
Okay, so another little quick conversation that we can have about database type things is to talk about Athena and Redshift, which are both data warehouse solutions from AWS. We have at Kelsus used Redshift a little bit, and in this case, it may be me more than Chris that has a little bit of experience thinking about these things. Although I cannot say I'm an expert in any way, but I can take a shot at it. So Athena is I think it's AWS's answer to Snowflake. So it's a new data warehouse that's based on putting data into S3, and then letting you use SQL, the SQL query language, on top of S3. So it's like your database is, just like any other database, like an Oracle database or a Postgres database or a MySQL database, but all the data is in S3. And the nice thing about that is S3 is really inexpensive storage. We didn't talk about that when we talked about S3, but gigabytes, terabytes, petabytes of data are affordable to store in there. And if you can suddenly begin to query across that huge amount of information, using standard tools like SQL, that's pretty powerful, because it lets you separate having a database with computers that need to run queries from having disks that need to be connected to running computers. So you only pay for the storage, and you're not paying, and then you're also paying as needed for the time that you spend querying. So in a data warehouse situation where you're not 100% up and, not serving millions of requests per second, but rather, few requests per hour maybe, or maybe hundreds of requests per hour, but just less than internet scale types of applications typically. These are, something like an Athena is pretty interesting. I think that one thing I've noticed about Athena is that I do think it's a fairly new entrant to the market, and Snowflake is kind of the king there. And just in my research, there's two advantages that I saw from Snowflake that Athena doesn't have yet. And one is that Snowflake is already ready to go for things like HIPAA compliant data storage and data retrieval. Athena is not in AWS's list of HIPAA compliant tools. And then the other thing is that Snowflake just has some more features that AWS Athena doesn't have yet. So, for example, Snowflake has this feature where you can turn on what are called data warehouses, multiple data warehouses, and each data warehouse is a little cluster of machines that are able to suck in some data from S3 and then make that available and highly queryable. And if you have say you have a bunch of health record data, and one group is wanting to look at that data from the point of view of outcomes, and another is wanting to look at that data from a point of view of maybe medical research, and they have completely different types of queries that they need to do, and the data in S3 is petabytes large. It's nice to be able to spin up different sets of clusters, different data warehouses that are independent of one another to be able to do those queries. And that's something that you can do with Snowflake that I don't think Athena supports quite yet. So that's Snowflake. That's sort of Snowflake versus Athena. And then the other piece is Snowflake versus Redshift. So Redshift has been around for several years. I know that a personal friend of mine who had implemented Redshift. I think this is public information because it's on his LinkedIn profile. He implemented Redshift as part of the underlying database for the NASDAQ exchange. And I know also, everybody knows that the NASDAQ exchange is involved in, billions of transactions per day. So I had seen that the NASDAQ had moved from an open source stack involving Hadoop and Cassandra over to Redshift in the past few years and is still using Redshift now, which tells you that Redshift is probably really good at having a whole lot of data and making it available very, very fast. And in fact, that is exactly what it's all about. And I guess a big difference between Athena and Redshift is that Redshift is more of a classic database. So the database lives on a computer, and the data lives in the computer's, the file system that's mounted on that computer, not in S3. So data access is maybe a little faster because you're talking directly to disks that's mounted on that computer. And then the other big thing about Redshift is that it's essentially just a Postgres database. You talk to it with SQL, just like you use SQL with Athena, but the structure of the database, the structure of the underlying data is different in Redshift than it is in Postgres. Main thing that's different about it is that it's stored in columns instead of in rows. I think I can say this in about a minute to make it clear what that might mean for you. So imagine you have a table that's got an ID, a name, and an age, and ID, name, and age, and maybe a location, like a city. In a classic database, you can imagine that it's like, 1 Bob, 39 Minneapolis, and then right next to that is 2 Mark, 15 Denver, and then on and on and on. And so if you need to, if you want to find the average of all the ages, you have to look across a lot of data. You have to look across each of those users and get the age out of it, and then put those together, and then do the average of the ages. If you store them in columnar format, all of a sudden now that same data looks like 1, 2, 3, Mark, Bob, Steve, 39, 15, 14, and Denver, Seattle, Minneapolis. I know I changed the data, but the point is all of the column data is together in the way it's stored. So if you want to find the average age, you just seek forward to where the ages are stored, and then right there, boom, all next to each other is 13, 59, 40, and you can find the average of those three very, very quickly. So for any kind of data where you need to look at the data in aggregate, Redshift is just awesome. It can be so fast at returning those aggregations. For any kind of data where you're doing a lot of inserting of new rows, or you need to look at all of the information in all of the columns in order to satisfy your queries, then Redshift all of a sudden doesn't look very good anymore. And then I guess the final thing about Redshift is that say you need to scale up or scale down, you kind of need to make a whole new cluster and then migrate your data to the new bigger cluster. Whereas with something like Athena or Snowflake, scaling up and scaling down is really about, adding more compute power and not, migrating all your data to a new bigger cluster. So that was a nice long monologue. Do you have anything to add to that, Chris?
No, that was a great explanation of that. And definitely, I think you're more well versed in that space than I am. So thanks for sharing that.
Right on. Yeah, I think we're getting close to the end here. Do you think it makes sense to touch? So there's another thing that we're maybe interested in and haven't been working with. I think it's worth touching on it at least. AWS has all these developer tools: CodeStar, Code Commit, Code Build, Code Deploy, Code Pipeline, Code9. They all start with code. Oh, Cloud9. Haha. They're trying to fake me out. So all these developer tools, and I don't think we're using any of them. And is it because it's just not in fashion with the kind of Node, JavaScript kind of group, or what are we going to start using some of these tools? And what are, I guess we could say what they are or say what they kind of are in aggregate.
Yeah. So this is Amazon's suite of tools for kind of managing a continuous integration pipeline as well as a continuous deployment. So it's all the various pieces of that. They're very full featured. I believe all these tools actually arose out of the internal tools that Amazon has built for itself for delivering all of its various projects and whatnot. So for us, definitely something for us to look at and keep an eye on. We have been using systems like Circle CI to do this for quite some time right now. And, Circle CI is absolutely a great solution. There's really nothing that it's not doing for us. So there hasn't been like this huge desire to go find something else and see, okay, well, how does Amazon's compare to what we're doing right now? Because there's just no pain. So we have Circle CI doing things like making automated builds, running automated tests, generating test artifacts and reports and code coverage. We have it doing automatic deploys for us into our AWS cloud. So we have continuous deployment going on. It's conditional based upon what branches we're committing to. It's fully scripted. So very, very full featured. That said, like all these tools that you mentioned on the Amazon side, they allow you to do all that, and then probably even more, right? So definitely something that we'll be keeping our eye on.
Yeah, excellent. I think it'll take that killer integration that they have that you just can't get anywhere else that will start to pull us in.
Mm-hmm. Yeah,
the kind of ongoing theme across both days here. Go ahead.
Mm-hmm. Yeah, and then Cloud9 is a little bit different in that Cloud9 it was an independent company. It's been around for quite some time, 5-6 years, where it's a browser-based IDE for developers. And so, that was one thing that Amazon didn't have. And I think about a year and a half ago, they made that acquisition. They purchased Cloud9. And spent a year, 18 months working on having it just be completely integrated in with all of the AWS stuff. So if you're a fan of a cloud-based IDE, it definitely makes sense to go look at it. Me personally, I'm really happy with Sublime, and I'm sticking with that.
Yes, IDEs are like your favorite. I don't know. They're like pets. They're like things that once you're really comfortable, or like your favorite old T-shirt or something. Once you're comfortable wearing it, you don't want to go wear a different T-shirt.
Well, it's such an investment, right?
Yeah,
because you spend so much of your day inside your IDE or your whatever it is, whatever tool you're using to write your code and debug and run it. So being as efficient as possible in that is very important, and to become really efficient in something, it just takes time, right? It's I don't know if it's the 10,000 hours thing, but it kind of feels like that, right? To really understand like all the various like keystrokes and shortcuts and tweaks and hacks and everything like that, just to get that much more efficient and comfortable with it. So switching IDEs ends up being like it's one of those things that it's like, there really has to be a good reason for doing this, because I've invested so much in my existing tool.
Right. So if they had bought Sublime and turned it into a cloud-based IDE integrated to all of AWS services, then would it be a different story?
Maybe. I would probably be pretty sad to see it go cloud-based.
Right.
Because it's kind of hard to. I mean, there's something to be said of just wherever you're at, even without a network connection or anything else, just be able to pop the lid on your laptop and write some code. And I'm sure all these support an offline version of it. And so at the end of the day, it may end up being blurred, and you really can't tell much of a difference, especially things with tools like the Atom editor and whatnot. So I'm sure going forward it will be less and less of a distinction, and may not even be able to tell whether it's native Sublime or cloud-based Sublime.
Right. Yeah. Yeah. And like we're already used to using Google Docs and seeing each other type on the same screen, and not having that not be the default modality or mentality in software development. It's maybe overdue. I don't know, but yeah, well, I'm interested to see where that goes. That could be a whole rabbit hole we could jump down.
Mm-hmm.
There's so many AWS as services. There's one more on our list that I'll just say its name is Kinesis, and I don't know that we want to spend time on it right now. There's other ones on the list too of AWS services. We can't talk about them all in 2 days, but I think the theme has come out that AWS services are best when they are super interoperable with one another and integrated tightly and give features that integration turns into magic. And that's why we've happily locked ourselves in, and why a lot of other companies have too, and why we expect to see just exponential acceleration in software development capabilities in the future because of what AWS is using and doing. So I don't know. Do you have any other closing remarks that you wanted to make, Chris?
No, other than I think we could absolutely do a part 3 to this of services that are neither core or interested about. Like, we haven't talked about IIM. We haven't talked about Route 53 and Certificate Manager. We haven't actually talked about ELBs, which are super, super kind of important and a critical piece. So we still have a lot of like the core fundamental stuff that we have not. We have CloudFormation, another great topic to talk about.
Yep.
So it goes to show just how big, just how full featured AWS is, and it's just increasing.
Right. Well, we have to make one of these a week for at least a year. We're hoping to do so. I bet we'll get to those eventually.
Awesome.
All right. Well, thanks everyone for joining.
Yeah. Thanks, guys.
Yeah, thank you. Well, dear listener, you made it to the end. We appreciate your time and invite you to continue the conversation with us online. This episode, along with show notes and other valuable resources, is available at mobycast.fm/09. If you have any questions or additional insights, we encourage you to leave us a comment there. Thank you, and we'll see you again next week.